Hello dear friends, in this video we'll talk about the working principle of differential protection. Let us suppose we have a step down transformer. This is 132 by 33 kV step down transformer. On the source side it is fed from a 132 kV bus, and on 33 kV sides it provides supply to a 33 kV bus, which in turn feeds the various outgoing 33 kV feeders. Say it's feeder 1, feeder 2, feeder 3, and so on. We place a 132 kV CT here and a 33 kV CT here. Let us say this is CT1 and this is CT2 on the 33 kV side. The connection of a differential relay is done like this. A differential relay is placed here. These three, CT1, CT2 and differential relay, they are all placed in parallel to each other. Let us suppose a current I1 is flowing into the transformer from the source end, and I2 like this is flowing on the secondary side of the transformer on the 33 kV side. Let's talk about the turn ratio of a transformer. Here V1 by V2 is 132 by 33, that is equal to 4. 4 is the turn ratio here, and voltage gets stepped down by a factor of 4, and the current in turn will get multiplied by 4 on the 33 kV side. Let us suppose we have a CT. CT1 has CT ratio of 300 by 1 amperes, and CT2 on 33 kV side will be 1200 by 1 ampere. Let us suppose a full load current 300 is flowing, that I mean to say I1 is 300 amperes, and let us say I2 will be 1200 amperes, because it's a factor 4 that's getting multiplied. This is the turn ratio, so current is stepped up by the same factor. So when 300 amperes is flowing on 132 kV side, 1200 will be flowing on the 33 kV side, and consequently in the secondary of these two CTs, the current direction, let's denote it by small I1, will be in the opposite direction, and similarly for CT2 the direction will be like this, and let's denote it by I2, and they will be equal to 1 ampere, and 1 ampere is flowing here. So this is the normal condition, full loaded, these CTs The current in these cities is to its threshold 300 and 1200, and secondary side 1 ampere is flowing. The direction of current is like this, and it will reach this point of the relay, and secondary on 33 kV side, the current direction in secondary is this side, will reach this point of relay. It will flow downwards, and this will flow upwards, and since both currents are of same magnitude, they will cancel out, and the net current, let us denote it by ID, differential current, it will be 0. Now suppose a fault occurs here outside the differential protection zone. The differential protection zone is the area between CT1 and CT2. This area is our differential protection zone. Now let us suppose the fault occurs here. The direction of current will be this way towards the fault point. So current on 132 kV side will be like this, and in secondary it will again be like this, and 33 kV the current will flow like this, and secondary side it will be like this. And similarly, as explained earlier, I2 will flow like this towards the relay, and I1 will flow like this towards the relay. Both will cancel out, and differential current will be 0, and differential relay will not operate. Now suppose the fault occurs within the differential protection zone. Let us say the fault occurs here. The direction of current on 132 kV side will be like this, and on 33 kV side will be like this towards the fault. Since the direction of current in secondary is opposite, it will be here like this, and this, it will flow towards relay in this direction. But this time for 33 kV side, the direction of current in secondary will get changed, because the fault current is in this direction. The current in the secondary will be in this direction, and the current will flow like this towards this point of differential relay. This I1 and this I2, they will get added up at this point, and the net differential ID will not be equal to 0. When the differential current is not equal to 0, it will make this differential relay to operate. When the differential relay gets operated, what will it do in turn? It will send a command to the breaker. We have two breakers, one breaker is here and one breaker is here. This is 132 kV circuit breaker, and this is 33 kV circuit breaker. Both of these breakers will trip when differential relay gets operated. So my dear friends, this was the basic explanation of how a differential protection works, and this works only when, this differential relay operates only when the fault occurs within the differential protection zone, and this differential protection zone is the zone that is between these two cities. Any fault occurring outside this differential protection zone should not and will not operate this differential relay. Now, suppose there is a wrong connection done. I will explain it like this. We have our step down transformer as explained earlier. This is 132 kV bus and this is 33 kV bus. We have a CT here and we have a CT on 33 kV side. Let us say what we do, we wrongly connected it like this, and this side we connect like this. So there is a wrong connection, and we have a differential relay here. Again, it's a 132 kV by 33 kV transformer with ratio V1 by V2 equal to 132 by 33 is equal to 4. We have a ratio of 4. So let us suppose that CT1 and this is CT2, similar to as explained earlier with CT ratios of 300 by 1 ampere, and this has a CT ratio of 1200 by 1 ampere. We have a full load current 1200 amperes flowing through this, and the source current will be 300. So I1 will be 300, I2 will be equal to 1200, and in the secondary side we will get I1 flowing in this direction and it will be equal to 1 ampere. I1 will be flowing like this and it will be, sorry, it's I2 and it will be equal to 1 ampere. So this current in normal condition will flow like this, and this current will flow like this, and like this, and it will reach this point. I1, that's 1 ampere, and I2, that's again 1 ampere. They will add up at this point, and ID, that will get added up and it will be equal to 2 amperes, and this will cause the differential relay to operate. And when differential relay operates, the breakers we have here, circuit breaker 1 and circuit breaker 2, this is 132 kV side breaker and this is 33 kV side breaker. Both of these breakers in turn will operate. It will operate, or we can say trip breakers. And in this condition, the transformer won't get charged even when there is no fault. We won't be able to energize the transformer in this case. So we have to ensure that the connections are done properly, like we have explained earlier. We have to put them in parallel, but we have to ensure the polarity. Let us suppose this is 1s2 and this is 1s1 and this is 1s2 and this is 1s1. So 1s2 should be connected to 1s1, and this is the wrong connection because we had connected 1s2 towards 1s1 here. I'll explain a little more about this. If we have a CT, this is the primary, this is P1 and P2, and we have its secondary, it is S1 and S2. Let us say this was our CT1 and this is our differential core of the city, and we have our CT2, it's like this. This is P1 and this is P2. This is S1 and S2. And this is our transformer. This is 132 by 33 kV transformer. This is our source side, so current should flow like this, and this will flow through the primary of the CT and should go like this. So we are placing the P2 side of the CT towards the feeding end of the transformer, and in this 33 kV side we are connecting the P2 side of this CT towards the secondary side of the transformer. Similarly, our secondary, it should be connected like the S1 to S2, S1 to S1 and S2 to S2, and this differential relay will be like this. It will be here. When we connect it in this scheme, then only we are able to create a protection zone, and that protection zone is the area that this is the area. This is our protection area. This area is getting protected by the differential relay. And if we do the connections wrong, and as explained in the next case, there will be the flow of current that will add up and cause the differential relay to operate, and it will cause the tripping. So I hope my dear friends, you have understood it properly how it's done, and in next video we will talk properly about how we connect three phases of these transformers through a differential relay. Till then, goodbye, see you soon friends.